Alright, in this video, I'm going to talk about how to find the domain of a function, and in particular, I'm going to talk about how to find the domain for a rational function. First of all, I'm going to review with you guys. The domain of a function is a set of all the possible x values that we can use, all the possible input that we can plug in into the function. And when we have a rational function, look at this. When the function is in the form of a numerator on the top over a denominator on the bottom, we have to make sure the denominator, the bottom, cannot be 0. If you have a 0 on the bottom of a fraction, it's undefined, right? So let's look at an example right here. First of all, this is how the question will be worded. We are going to determine what state the domain, and here's a keyword, domain of a function right here. So you must know what does this mean, right? Otherwise, I cannot proceed. And more importantly, you must know how to set this up. This is the restriction that we have to make sure. This is the things that we have to make sure that it doesn't happen for the bottom to be 0. So right here, when we are given a rational function like this, all we have to make sure, okay, we have to make sure nothing goes wrong. Well, in this situation, we only worry about the denominator, the bottom. We are going to make sure the bottom, so let's put it down, 3x minus 15. The top is okay, just the bottom we have to worry about, and this cannot be 0. Okay? This is the setup, and once you can set this up, the rest is very easy, because all I have to do now is, of course, add the 15 on both sides, and then you see this is 3x cannot be 0 plus 15 is 15, and divide both sides by 3. Cancel, cancel. I have to make sure x cannot be 5, right? Because if you look at my previous example, if I plug in 5 into here, you know the bottom will be 0, and the whole thing is undefined, right? So this is the procedure. This is how you work it out. You have to tell me x cannot be equal to what? This is the restriction, okay? So at the end, this is how we are going to write down the answer for the domain. We are going to use the set builder notation, okay, most of the time. And that's what we mean by this. We first draw a left brace like that, and then we put on x and with a vertical bar. This means it's the set of all the x values such that, okay, and then I'm going to close the brace. This is the set notation. And then when you have x, such that, right here, you are telling me the condition. You can use any x value except for x being 5. So right here, I'm just going to enter this in here. X cannot be 5. This right here is how we are going to present the domain for this function. And now let's look at another example. All right, now another function, okay, this time we have 2x minus 16 on the top over x squared plus 8x plus 12. Well, this is a rational function. We have to make sure the bottom cannot be 0, right? So this is the bottom, and whenever you're doing domains, I will really recommend you guys to write down. We are going to make sure so this doesn't happen. So you know we are setting the restriction. We're preventing this is going bad, right? So anyways, we are going to make sure the denominator, which is x squared plus 8x plus 12, this, I don't want it to be 0. The top, if the top is 0, it's okay. We have seen that in the previous example already. If the bottom is 0, the whole thing will be bad, right? So make sure this right here, this cannot be 0. And now, how do we solve this? The usual way, we factor, and then work it out. So this is not bad because I know I must have x and x. What times 12 give me 12? Together, they add up to positive 8. The answer for that is plus 2 plus 6. Okay? So that's the factoring, and now this is not equal to 0. Two things we have to make sure. This time, we have to make sure x plus 2 cannot be 0. And on the other hand, x plus 6 cannot be 0. What does this mean? This tells us that x cannot be negative 2. Okay, we just minus 2 on both sides. And right here, x cannot be negative 6. We just minus 6 on both sides. Okay, and at the end, once again, we write down the domain in the step builder notation. So it's always like this. You can imagine this is like a gift box. It's always look like this, okay? And you put these things in the box for the gift, just like your Christmas gift. Anyways, we put this down, which we have x cannot be negative 2. And then the other condition is x cannot be negative 6. Okay? So this is the domain. And once you know the setup, once you know what to do, then we just have to do it. And one more special example for you guys. And for the third one, I'm going to use h of x, and this is the expression for that, right? And once again, to find the domain, we look at the denominator. Don't do anything with the top for the domain. We have no worry on the top, okay? We say that 3 times already. This is the third example. All we have to do is, let's make sure what? Make sure the bottom, which is x squared plus 9, I cannot have 0 right here. And now, how can we solve this if possible? Well, can I factor this? No, right? Because this is x squared plus 9. The sum of 2 squares is not factorable. What can we do? Let me just subtract 9 on both sides for you guys like this, okay? And I'm going to talk about the things that I want to point out here. Well, after we subtract 9, we see we have x squared, and we have 9 equals to negative 9. And let me ask you, is it possible to fill in an x value so that after you square that, you get negative 9? Is this ever possible? Well, no, right? If you put in 3 squared is positive 9, so, okay, it's not negative 9. If you put in negative 3 right here, in the parentheses, negative 3, and square that, you still get a positive 9, right? This right here has no real value solutions. It's not possible for this to happen, right? Unless you use complex number, the imaginary number I. But at the moment, we don't need to worry about it, especially for domain. There is no real numbers that will make this happen, right? So this right here is not possible. So let me just put down not possible for this to happen. But then, well, in this case, when you are talking about domain, when you are right here, an equation that we cannot solve, not possible. This right here, the function means no worry. Okay, no worry for this. Because no matter what you plug in for the x value, the denominator can never be 0. That means no worry. And this is how you are going to write down the domain, okay? Well, a few things you can do. You can just write down in words. X is all real numbers, so that's totally fine. Or you can just put this down. Set builder notation, and you can just write it down. All real numbers. Seriously, there is no worry at all. And I'm just, write it down right here for you guys. That's for the domain. So, in conclusion, set the denominator not equal to 0. If you are able to solve this, then those are the bad numbers. You have to prevent them from the domain. If you end up with equation right here, well, with a not equal sign, if this is not doable, that means the original expression, we have no worry. That means x can be any real numbers. Okay, all real numbers. That will work. And this is how you find the domain for a rational function.